again. So I'm gonna do a video to show the, go over the review that I posted, the chapter review for the test on Wednesday. I'm gonna share my screen, so hold on. And yep, you see that little cursor over there? It's just having its own little moment right now. I gotta wait for it. There we go. Hold on. And get rid of all this stuff. There we go. So I've opened it with Cami so I can write on it. And the first one is all the words and terms that can represent input and output. Well, actually, I like to do the table because it does relate to the table. But input at Xbook. So I'm going to do it like my rhyme. Independent, dependent. Domain, range, x-axis, y-axis. Ain't that strange? So it's too hot. I'm gonna take it off, check it off. X and Y, but it could be the x-axis. The x-axis, what does it run? X-axis runs horizontal. And the y-axis run, so x-axis, y-axis. That's vertical. Another thing, this is the input number. This is the output number. There's lots of words that go, and these are good to know. What's missing? Well, sometimes Y, sometimes we use this notation and we're, this is of course the X, but this is, instead of Y, they call it F of X or G of X or H of X or something like that. But it has that other version. And this, if you're doing science, this is cause. And this is effect, because I know some of you are taking some science classes and you do have to pass some science to get your diploma. So the science teacher said, yeah, why don't you include that information too? This cause and effect does not usually show up on a math test, but it's still there. I can move these around a little bit. So there's a lot more than just the one, but I've always thought that rhyme. Independent, dependent. Let me see, where I get the camera? Where I go? Independent, dependent, domain, range, x-axis, y-axis. Ain't that strange? Gotta be silly. That's the way it's on. Okay, here we go. Identify the range for the function given this domain. So you may not have done one like this, but there are going to be a few more. This is the domain, which means these are the x's. So the x's are 0, 1, and 4. And what happens a lot of time, and I'm going to keep using the, is that what I'm used to organizing this, and I find it very helpful, is to organize it with a, let me see if I can draw that straighter. Not too much straighter. With the x's, and then here, well, here, that's the input, and then this is the output, the y. How do you figure out what is y? Y, how do we get the y? From going 2x minus 4. So this part right here, that I'm going to write here, 2x minus 4, that's what we call the function rule. And I know. So I'm going to put in some numbers, x, and which x's am I going to put in? I'm going to put in 0. I'm going to put in 1. No, I still want my text box. I'm going to put in 1, and I'm going to put in 4. And that, they told me right there, over there, 0, 1, and 4. So those are the x's I'm going to use. And then I'm going to take where this x is, I'm going to replace that x with the number. So instead of 2x, I'm going to go 2, 0. But when I put the 2 and the 0, I have to put the 0 in parentheses. This 2x means 2 times x. And so to multiply, I'm going to show that with parentheses. So that's 2x, and then I have to go minus 4. Now you can either work it in your head or on the calculator. I'm going to go 2 times 0. That's 0. 0 minus 4 is minus 4. You can just type that into any old calculator and get that. Now I'm going to replace, instead of 2, 0, I'm going to say 2 parentheses 1, or 2 times 1. Oops. Let me get that replaced. And then minus 4. Double the x, and then subtract 4. So I'm going to take my x, 2 times 1, and then subtract 4. So 2 times 1 is 2. 2 minus 4 is negative 2. So I've got 2 numbers. I got the last one. So this one, 2 times 4 minus 4. 2 times 4 is 8. And then 8 minus 4 is 4. So I've processed all of my input numbers. I put them into the function. So what is the range? The range is, it's a set, it's a discrete set of numbers. I've got a list of x's, I have a list of y's. Negative 4, negative 2, 4. And again, you can write those in any order. And again, I'm not using the parentheses. Those parentheses are for ordered pairs when there's an x and a y. This is not an x and a y, they're all y. So I use these wiggly ones. So that's the range. That's how you figure out the range when they give you an equation. So they give the equation y equals 2x minus 4, and then they give you some x values to put in there. So this part is called the function rule. All of it is the equation or the function. And because it says domain, then these numbers are x's. 0, 1, and 4. You just take one at a time and do that. There's a way on a fancy calculator to type it in and put it in the table and get it to do that. It's not going to save you a lot of time right now, especially since we don't have those just handy. But this is just as quick. You know, you're just going to have to take the 0, put it in, then the 1, and then the 4. Let's look at this one. Determine the domain and range of each relation. So these are these discrete or continuous? How are we going to do that? Are we going to make a list, or are we going to write something out? Well, this is 3 ordered pairs, which means this is 3 dots on a graph. If I was going to, I could graph this here. 0, 5 would be up here. 1, 2, 3, 4, 5. There'd be a dot right there. 2, negative 4, go 2 over 2 and then down. 2. Negative 4 would be somewhere around here. 7, 0, 2, 3, 4, 5, 6, 7. So I'd have 3 dots, and they're not showing up, you know. So this is discrete. But what's the domain and range? So this is, I don't know. For me, it's the easiest kind. It's when you just list them. So the domain are all the x's, 0, 5, 7, and range We use the wrong. Now the second one's 5, -4, 0. It's domain and range. This is going to look the same. These, whoops. I'm not going to write it all out. That's your domain. That's your range. It's going to look like this with a set of numbers. Number 4 would have 10, 2, -5, and 0. Well, maybe you should see that because I want to make sure you know you don't type them in separate. So there's 10, 2, -5, 0. I don't type the 0 twice. It's already in there. You don't have to put it in again. So that's the domain. And when we're doing this, sometimes I just put D for domain, especially when you're running out of room. And R for range. Range would be these numbers: 4, 2, 5, 0, -10. Now, while we're at it, is that a function? It says it's a relation. They use the word relation, but is this a function? Is this a function? This one, yes, is a function. But this one is a function, yes, and this one is not a function. It's a relation. It's a set of ordered pairs, but because the 0 repeats in the x's, that's not a function. They might ask us here. So here, this is domain and range in a different way. And again, I just posted a video to review domain and range for all the different ways. So domain, we're going to ask how far to the left and how far to the right. This is not a list of numbers because this is connected. It's continuous. It's not discrete. If it's discrete, you're going to have a list of numbers. And I'm waiting for that. Again, this is discrete data. It's just dot, dot, dot. And so it's just a list of numbers. But this is not going to be a list of numbers. I'm going to have to think how far to the left and how far to the right. Well, it's going forever this way and forever this way. So this one, you should know, hopefully you can say it. You know what's coming. All real. Looks weird, doesn't it? All real numbers. Let me get that back here. Because it goes forever, forever. Now for the range, I need to be looking down and then up. So how far down does it go? Well, it goes down forever. I can see the arrows. So, but it doesn't go up forever. But where does it start? It starts right here, but I'm looking at the range. So I want to look at the Y, and that is at a 2. So those are the Y's. And from that 2, from the 2, it's going down, 2 down. So it's going less than. And I have got to use this part here to get the less than, because it is less than or equal to. Okay. This is weird how this happens. I'll get the less than or equal to. No, okay, I need to go back to my textbook. Oh, this is weird. I have to, it types it there and then I have to move it over there. That's the weird thing about this Kami. Why? But there is I want you to, because at the 2, it's a solid line. So it's got the little equal sign with it. And then our number here is 2. I'm trying to make it perfect, doesn't care. It's nice when it is on the line, so. Y less than or equal to 2. And that's the domain and range for this one. From there down. Okay, what about number 6? How far to the left and how far to the right? Well, this one's got a weird thing going on. One thing is this is not a function. Right away I can see it's because this is a straight line. And there is a dot right there. So you look really closely. At the top is a solid dot. At the bottom, no, my eyes are bad. That's a dot as well. So this is going to have a weird one. Let me see if I can do this with the equation. So I am going to say how far to the left, and it goes as far left as -3. And then it's less than or equal to, there's always less than with these, but there is a solid line there. And then how far to the right? Well, it goes as far right as -1. Let's get that to where you can see it a little better. I know this shouldn't take this long, but it does. And then that's how I can move it back into where. So that's the domain on that one. It goes from, it just stays right in here. It doesn't go forever. It just really plays between -3, doesn't get past there, and over here to -1. I'm just, hopefully you can see my cursor. Now I'm ready to do the range, which is up and down. So we're going to always start at the bottom. That's kind of the tricky part here, the bottom. And let me get this bigger to start off with. Now as far down as it goes is right here. 1, 2, 3, 4. It goes from -4. And that is less than or equal to. We always use the less than. You never point to the right. It's always pointing to the left. But this time it's a story about the y's. And it's also less than or equal to. And how far up? 1, 2, 3, 4. It goes up to the 4. And I like doing this with pencil because I like to write it I don't like to write it just from left to right. I kind of put my left and right numbers in, and I'll show you what I do actually. I don't know if that makes sense, but that's how my brain works it. It's hard for my brain to work it the way I just wrote it. Really what I do when I'm doing domain and range with these, number 6, is I first start out, because I know that it's got a start and a stop. Let me see where I have room to write this. Oops. It's X in the middle, and then it's got a less than and a less than on each side. And then the range is got there. So I get this written down first. That's the way I really write it. And then I find out what's the left number for the domain, what's the left number and the right number. So the left number goes -3. And then I say, what's happening at that -3? Well, it's solid. And how far to the right? Well, it goes to -1. And that's solid. So that I fill that part in. Because I know, again, with the range, I'm going to start with this. Range is going up and down. They always go less than when we do this, and we always put the low number here and the high number there. So how far down? That's -4 included. And how far up? 1, 2, 3. Yeah, I got it right at the first time. So that's really how I like to write it. But this program makes me write it in left to right, and I don't like that. Or I would think it out first this way and then write it out. So that's domain and range. And there's a lot of different ways to show it. You can show it with the lists. Sometimes the answer is forever, forever. You write all real numbers. Sometimes you have an open end, goes forever one direction. So you write something like this. And sometimes you write like this, where it has a beginning and an end, beginning and an end. So there's those different ways. And there's a review I just posted about how practicing the domain and range in the different ways, because there's those like basically 4 ways that you can do it. This should be an easy part when we say, is this relation a function or not? Basically, you're looking for these 3, whether or not the x's are repeat. 4, I'm just looking at the 4, the 0, the 1, and the 7. So if this one is yes. I don't like that. Let's go. Yes, it's a function. Why? Because the x's don't repeat. Here, not a function. Why? Because the -2 is repeating. It shows up twice. You only have to look at the x's. You don't have to look at the y's, just the x's. Number 9, that one is a function. The x's do not repeat. Now, to check on a graph, this is where we're using the vertical line test. Just straight up and down. If you can ever connect at all, if it can touch twice, going up and down. And I'm checking this one. Nope. They're all playing in their own lane, so this one is a function. It passes the vertical line test. I can move that line up and down here. It's never going to touch twice. That's a function. Number 12 is really just like the first 3, except that the x's are running horizontal rather than vertical. So I need to look across and to see if any of those x's repeat. They do not repeat, so that one is a function. We're still, this one, is this a function or not? On the mapping, you're just saying, does each x, is it only going with one y? And that one's pretty straightforward. That one is a function. All the x's are unique. Now, this is the one that gets tricky. Now, you want to make sure that that this 5 is only connecting with 1. And the 3. Now, they happen to go the same one, but that's okay. What you can't do is have like the 5 go over here twice. If it did that, that would not be a function. This one is okay. It's just watch out for any of the input numbers of the x's that have a split arrow by them. What do you think on this one? This one is not a function. Right here, there's a vertical line, and right there. If at any time you see it touch twice, well, this touches a bunch, then that's not a function. So those are some amazing ones. Now here is one that you may not have a lot of practice with. It's very similar to this number 2 that we did just a while ago. I have an equation and I had a set of domains, and we're going to find out what's the range. So this is very similar. I have a function rule. Now it's not in the table, but this is what I need to keep my eye on, 3x minus 2. And my x's, I'm going to put those in. So that's -2. Then here, 0, then 2, and then here, 3. Get it? Can I get a 3? 3. So now to figure out the y, I'm going to have to take that -2, and I'm going to use the 3x minus 2, 3x minus 2. But instead of the x, I'm going to take the x out, and then I put -2. But when I put the -2 in, I've got to put the parentheses. So it'll mean multiply. Otherwise, it won't mean multiply, because 3x means 3 times x. So 3 times -2 is -6. -6 minus 2. Now what's my y? -8. Now, if you need help, this is what you'd put into your calculator to figure out the -8 if it's not doing it in your brain. Same thing here, except, again, my function rule is 3x minus 2. Where the x is, put in parentheses and put your 0. 3 times x minus 2. 3 times 0. 3 times 0, 0. 0 minus 2. This one is equal to -2. -2. Try it again. -2. Zero minus 2. And we're just going to keep doing this here. Now 3x minus 2. Go back to the x. X comes out. What comes in? A 2. But it has to come in with the parentheses. 3 times 2 is 6. 6 minus 2. You got it. Equals to 4. 3, 3, 3, 3 minus 2. No, not minus. That's why I like to go ahead and type it in 3x minus 2 and then go back to the x and then get it out. 3 times 3. 3 times 3 is 9. 9 minus 2 is 7. That's equal to 7. So I have my x's that I came out with. They told me at the beginning, the domain. Domain is the x's. So these were my x's, and now I have the y's. Now this means, I'm still in here, that I have a point, x, comma, y. And so I could rewrite this as an ordered pair, -2, -8. And -2, -8 happens to be, oh, I scribbled it. There it is right there. And you're going to go find that other point. 0, -2. Where's that point? There's the x, whereas x is 0. And remember, -2 is the y, so it's going to be right there. Let me do a little. There we go. There's my -2. I forgot the parentheses here. And this is the point 2, 4. Let me draw, and let me do this here, and this is point 3, 7. So each of those gets a dot. Let me get to draw over 2 up 4. There, and over 3 up 7. You know, they're not perfect, but that's pretty good. So now, and remember, I do want to show you this because this is a function test, and this one is really not written as a function. What you're probably going to see is something that might look a little bit like this. So just be prepared. F of x equals 3x minus 2. And instead of saying y here, they'll say, this will say f of x and f of x. And so you might even see something that looks like this over here. What is the function of this value? What's this worth when x is 2? And I wish I had more room. Do I have more room over here? Yep. F of 2 equals -8. So notice the one inside the parentheses, that's your x. So -2 is the x, and what it's equal to is the y. This is the x, and this is the y. This one could be written like this. F of 0, what is the value of this function when x is 0? Well, it happens to be -2. And so forth. F of 2 equals 4. But look at the relationship between those two notations. This is the x, and this is the x, this is the y, and this is the y. Maybe it's too much stuff right there. Where's my cursor? Let's get this out of the way. And just because we're doing all of them, we'll just go ahead and f of 3 equals 7. Yeah, I don't know how much to go because I'm not hearing your questions live, but hopefully this is going to help you study for the test. That's that part. So that's the big chunk of it. Now here's a little bit something that takes a little bit more practice, a little bit more just thinking, not calculating. You have to think about it. You're making treat bags for a birthday party. Each bag contains 6 items. Write a rule for the number of items used as a function of the number of bags. So I like to use the letters. So the number of items is a function of the number of bags. Something like that. So how do I figure out the number of items? Well, it's 6 items per bag. So you count how many bags and multiply by 6, you get the it might look more mathy like this. I said, I'm not a good typist. I'm good. I know my math. Okay. The number of items is a function of bags. So to figure out the number of items, I'm going to go 6 times the number of bags. It might look, we use 6b. Or if, keep it kind of mathy in the XY language or the function notations, f of x equals 6x, and x represents the number of bags. Which one is independent and dependent? Independent is the one inside. So independent are the bags, and dependent is the total items. And the number of items depends on the number of bags. So this one depends on that one. And again, I just kind of, for independent, I look for the one that's inside the parentheses, or it's the function of, and whatever says after of is the independent. That's another way to look for that. If it says function of, after function of, whatever that is, after the function of, that's your independent. And dependent is like, what do you get from that? It's the number of items. So the number of items is the independent. Is dependent. Dependent is what the whole thing is. Just the in, now, I know that is confusing because I've kind of circled both of them, right? The one in parentheses, independent, in parentheses, independent. Maybe that'll help. How many items we need to make 12 treat bags? So to get 12 bags, oh, no, 12 times 6, 72. 72 items. Yeah, okay, that's not working. Yeah. I got a little distracted because it did something weird, but you do kind of want to label that. That's items. That makes it a better answer, is to put the number in the thing. Your grandma has a pine tree in her yard that drops a lot of pine cones. She will pay you 10 cents for each pine cone you pick up and bag. She also gives you $5 for just showing up. So what do you get paid? This is a classic linear equation. This is good to know. So what you get paid is going to be equal to $5 plus 10 cents per pine cone. Right? Let's read that again. Pine cone. But you get $5 no matter showing up. You could earn as a function of the number of pine cones. Yeah. And so if you could talk about if pine cone becomes your X, it's a function of the number of pine cones. So independent, look for function of pine cones. What do you get out of that? What comes out of that? Your pay, your total pay. You might get some cookies or something from grandma too, I don't know. If you pick 200 pine cones, how much money would you get? Oh, let's see. Well, what am I going to get paid? I'll get paid $5 plus 10 cents. And who had the patience enough to count 200 pine cones? Not me, but hey, grandma wants to count out 200 pine cones. Grandma can count out 200 pine cones. But I'm going to have to multiply that out. I'm going to do the multiply first. And I'm using a calculator, but you don't need the fancy one here. Just go 200 times 10 cents and then add $5. You get 25 bucks and a headache for counting out 200 pine cones. But I wouldn't say no to 25 bucks. So that is a little section on independent and dependent. And here's another section. And we'll just let this go on and record. Given f of x equals 2x plus 4 and find f of 6. You definitely will be, there's going to be something like this on the test. The one inside the parentheses is the x. Now, it has to be in the parentheses because there's a different kind that's not. So that one is going to go right there where the x is. And so I'm going to go, it says 2x plus 4. But instead of x, in parentheses, I got to put the 6. And what is that equal to? Well, I got to work that out. Got to move the cursor. So 2 times 6 is 12. 12 plus 4, 16. So f of 6 equals 16. The value of this function at 6, when x is 6, is 16. The y value is 16. They give you the function rule, 12 minus 2x, and the x keeps changing, 12 minus 2x. but I'm going to use a different x. Take the x out, put in -3. Now this part here, I'm going to do that first. Negative and negative makes positive, so that's 12 plus 6. This one is going to be 18. Again, just type it into your calculator if you're having some issues. If any of this is not working for you, you just give me a call or a text or something. I'll try to help out as best I can. 12 minus 2x, that's what it says. 12 minus 2x, take the x out, in parentheses, -1. I'm going to do the multiply first. -2 times -1 is plus 2. 12 plus 2 is 14. 12 minus 2x. X is going to change this time to a 2. Just a positive 2. 2 times 2 is 4. 12 minus 4 is 8. I'm not taking time to show the calculations, but you know, just use your calculator. Are we through yet? Oh, we got 2 more. We can do this. Aha. Oho, or whatever. Be careful. Watch out for this one. This one will trick you up if you're not watching. So this one says find x. I don't know what x is. So I can't put a number in here because I don't know what it is. What is that? I do know what comes out. The number that comes out is a 12. So here's what I know. If I take 2x, let's see, let's go back to that color. 2x plus 4. Plus 4. I don't know what x is, so I can't put a number into x, but I do know what it's equal to. It's equal to 12. And this is where we start. So again, this is the one that'll trick you if you're not paying attention. So if f of x is 12, if my function, if what comes out of it is a 12, what number did I start with? Well, what I'm going to have to do, and now I am going to switch to rojo, is I'm going to have to solve for x. Like, what is that x number? So I keep my eye on x, or I say put your pencil on the x, and we're going to get rid of first whatever's add, subtract. And in this case is that 4, that plus 4. So what I'm going to do is I'm going to do the opposite of plus 4. Oh, it either does all one color or all the other one. I got it. Okay. I'm still learning how to use this. Okay, I know. Okay, so I want to get rid of the plus 4, so I'm going to go -4 on both sides, -4. So right there in the middle, which I don't want that blue thing to show, but you can see with the plus 4 and the -4, that is going to cancel. That's what we usually say. It cancels out, or it makes a 0. And so then I just have on this side 2x equals, and then I'm going to go 12 minus 4, which happens to be 8. And that's what's next. And then what I can do, you got it, I'm going to, let me see if I can draw this better. I need to split the 2 and the x, so I'm going to divide 2, divide 2, solve for x. What is x? Well, x equals 4. So that, hopefully you've gotten enough practice with that through the different classes at Excel Center. and you can come up with that x equals 4. The tricky part is seeing, because this looks pretty similar to the other one, but because, you know, when they say find x, you've got to really pay attention and set it up just a little bit different than you would the other one. Now 22, I don't think I'm going to have one that's worded like this just yet on this quiz, but it'll show up down the road. It says find the 0 of the function. You're like, what do you mean 0? You may know that, you may not. But it tells you, plug in 0 for the output and solve for x. Now output is the y. So output is this. So this one, we're going to get there later. This one's again, we're solving for x. That's just like what this one is. It says solve for x. So solve for x, and what is this equal to? It says plug it, make it equal to 0. So here's where I need my x. The one that's touching it, the 7, hold off, we'll do that later. We want to go for the add subtract number first. So it happens to be that minus 28. So to do the opposite of minus 28, I'm going to go plus 28. Let me try that again. Plus 28. Plus 28. What do I have left? Well, that cancels. And what I have left is 7x equals 28. Divide 7. Again, this is, I don't know why, that's pretty rare that they're both the same answer, but they happen to both say x equals 4. Done, we did it. Again, hopefully that helps. I've got lots more reviews, so I'm not posting all of it because I don't want to make you crazy. But if you need more review, I've got more practice to do. But I'm just going to leave it for those right now, unless someone requests more.